In this video, I'm going to demonstrate how to control standard servos using the DynamixShield and an Arduino Due. I'll be using two different servos. The first is a high-tech HS475 HB servo. The second is a Grove micro servo. Let's start with the high-tech servo. It comes with a 3-pin connector that has a black ground wire, a red hot wire, and a yellow signal wire. This connector is not polarized, so you can connect it the wrong way by accident if you're not careful. Let's plug it into the shield. On the top of the shield, there's a 3-pin header row where you can plug in things like standard servos or RobotGeek sensors. You'll notice that it's labeled ground on the top of the header row. Make sure your black ground wire plugs in at the top. You have 11 pulse width modulation connectors available on the shield. These are D2 to D13. All of these digital lines have bidirectional level shifting from 3.3 volts to 5 volts. Also, the power supply for the pulse width modulation line is controlled by jumper J14. The center rail of J14 goes to the digital header supply lines. You can use a jumper to connect that rail to either the 5 volt power supply from the Arduino or from a power supply plugged into the shield. If you use the 5 volt from the Arduino though, then make sure you do not exceed its maximum current draw. Servos consume a lot of current, so you would only be able to power 1 or 2 in this manner. If you do accidentally try and pull too much current though, then the PTC fuses on the shield should still protect your Arduino. If you need to run more than a few servos, then you should use the external supply for the shield. Just make sure that you're using the voltage required for your servo. Different servos require different voltage levels. Also, if you're trying to control Dynamixel and regular servos at the same time, then you'll either have to have a regular servos that run at 12 volts, power them from the Arduino, or take the jumper for J14 off and use another voltage from an independent supply applied directly to the middle rail, while also making sure to connect ground as well. We've connected our servo up to the D2 line. This is the one closest to the SPI pins and is labeled D2 at the bottom. For this demo, we'll also use a RobotGeek potentiometer knob. It also uses a 3-pin connector that connects to the analog header row. Once again, the top of that row is labeled as ground. Let's connect it to the A0 slot. We'll be powering the servo from external sources, so I'll set the jumper J14 to EXT. I'll use a 6 volt power supply for the servos. And then let's connect up the USB. From the computer to the programming port on the Due. And our hardware setup is now complete. Now let's load our sketch to control the servos. Let's go to the DynamixShield repo, sketches, and then load the regular servo sketch. This sketch first includes the servo library so that we can control our servos. Then has some constants, one pin for the servo, the pin ID for the servo, and for the potentiometer that we'll be using. Within setup, it attaches to the servo and turns the potentiometer into an input, then starts up our serial debug port. Within loop, we first read the potentiometer, which puts it in a buffer. We're going to calculate a rolling average so that we can get a good average of what the value it should be is, so we don't have any jumpiness in it. So after we read the potentiometer, then it calculates the rolling average value that we'll be using for our sensor position. Then it maps that analog sensor position into something for what we want the shaft position to be. Then it uses the servo write to actually set that position for the servo, and then it prints it out and then just delays a bit before the next time. Now let's check that we're set to the Arduino Due programming port and the correct port number. Then upload our sketch. And now as we move the knob from the RobotGeek sensor, it moves the position of our servo. One last thing that I'd like to demonstrate is swapping out this servo and the RobotGeek knob with a Grove microserver and a Grove knob. Let's go ahead and unplug the power and computer and then plug in our servo and knob. This is the Grove microserver. We're going to plug it into the pulse width modulation 2. And this is a Grove knob. We're going to plug this into the A0. Finally, we just need to connect our power back up. And once again, as we turn the knob, we can control the position of our servo. And it's just that easy to swap in new Grove parts. If the Dynamixshield is something that you're interested in, then please support my Kickstarter for it so I can produce it commercially and make it available to the public. Thanks for watching.